Good morning. Today we are going to review the AP Calculus series of convergence handout brought to you by NIMSY.
When a sequence converges, that means that as you get further along the sequence, the terms get closer and closer to a specific limit, usually a real number. Something diverges when it doesn't converge and the limit approaches infinity.
We will be going over today problems 14, 15, and 16.
Crazy calculus.
Number 14 asks, which of the following series converges for all real numbers x? A,
Ding,
B,
ding,
C,
ding,
D,
ding, ding,
or E?
ding.
An easy way to solve this problem is to find a number that would make each series diverge, so we know it can't be that answer. For A, we can plug in x equals 1, and we know that 1 over n diverges because it's a harmonic series. For B, we can plug in x equals e, and if we use L'Hopital's rule, we find that the limit as n approaches infinity is infinity, and therefore it diverges. For C, we can plug in x equals 1, and we know that 1 over the square root of n diverges because of the p-series test. For D, we can use the ratio test to determine the convergence of series, taking the limit as n approaches infinity of 1 over n plus 1 times the absolute value of e times x, we get 0. Therefore, the series converges by the ratio test. For E, we can also use the ratio test, and taking the limit as n approaches infinity of n plus 1 times the absolute value of 1 over e times x gives us infinity. Therefore, it diverges. So the correct answer is D.
Ding, 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 ding. For number 15, the question is, what are all values of x for which the series 2 divided by x squared plus 1 to the n power converges? So by the geometric series test, the series converges when the absolute value of 2 divided by x squared plus 1 is less than 1, and this implies that the absolute value of x squared plus 1 divided by 2 is greater than 1. Therefore, x squared plus 1 is greater than 2 equals x squared minus 1 is greater than 0. So x plus 1 multiplied by x plus minus 1 is greater than 0, for x is lesser than negative 1 and x is greater than 1 only.
Number 16 asks, for what values of p will both series 1 over n to the power of 2p and p over 2 to the power of n converge? So in order to determine whether or not a series converges, we can use a variety of tests. By examining the series, we can see that the first one is a p-series and the second is a geometric series. A p-series converges if p is greater than 1 and diverges if p is positive and less than 1. A geometric series converges if the absolute value of r is less than 1 and diverges if the absolute value of r is equal to or greater than 1. Here, C is correct. Let's use the value 1 to test. For the first series, C works because the exponent of n is greater than 1 given these values. For example, if you plug in 1 for p, p will be 2, which is greater than 1. C also works for the geometric series because r will be less than 1 if you plug in 1 for p. The other answers are incorrect because they include intervals with values that will make one or both of the series diverge.
Hey Miriam, do you know why I like the number 5 so much?
Why? Is it because that's what you're going to get on the AP exam?
No, I'm gonna get a 1.